Alright, ladies and gentlemen, welcome back. In this video we're going to look at derivatives of inverse trigonometric functions. We're going to look at the rules for those and look at where some of them come from. Just in case you get in a pinch, you can always derive them. The first thing I want to do is point out to you the connection between the inverse trig functions and their cofunctions and their derivatives. Notice with the derivatives of arcsine and arccosine, the derivatives are identical. Their only difference is that the arccosine has a negative sign. Okay, so the derivative of the arcsine is 1 over square root of 1 minus u squared, and then the chain rule application. The derivative of the arccosine is just the opposite of that, negative 1 over the square root of 1 minus u squared. We have the same relationship between the arctangent and the arccotangent. The derivative of the arctangent is 1 over 1 plus u squared, and then our chain rule application. And the derivative of the arccotangent is just the opposite of that, negative 1 over the quantity 1 plus u squared. And then lastly, the same relationship exists with the arcsecant and its cofunction, the arccosecant. We've got 1 over the absolute value of u times the square root of u squared minus 1 for the derivative of the arcsecant, and the derivative of the arccosecant is just the opposite of that, negative 1 over the absolute value of u times the square root of u squared minus 1. So those are the rules. You'll want to know those and be able to use those in order to find derivatives. We're going to actually look at the derivation of the arcsine, arctangent, and arcsecant. It's probably going to take the next 2 videos to look at all of these, but we'll start right now with the derivation of the arcsine. Why is the arcsine derivative 1 over the square root of 1 minus u squared times du dx? I think it's good. I'll tell you, when I took AP Calculus way back 30 years ago, my teacher basically gave us these rules and said, okay, those are the rules, write them down on an index card and memorize them. And they never really stuck with me, and they still didn't stick with me until I started teaching them, and I thought about where do these rules come from and why they are what they are. And then when I'm in a pinch, if for some reason I blank out on what one of the rules is, I can always develop it using the techniques that you're going to see in this video. So the first thing I'm going to do is I'm going to let y be equal to the arcsine of u. And then in order to find this, I can use a little bit of algebra, trigonometry, and previous techniques that we've learned for finding derivatives in order to come up with dy dx for the arcsine. The first thing I'm going to do is I'm going to take the sine of both sides of this equation, and I get that the sine of y is equal to u. And then I can take the derivative of this function, and the derivative is going to be cosine of y times dy dx is equal to du is equal to du dx, pardon me. Alright, and now I want dy dx. So dy dx is going to be equal to 1 over the cosine of y times du dx. Now writing this as 1 over cosine of y does us no good, because y was a variable that I introduced in order to set the sine inverse equal to something. I want this derivative rule to be strictly in terms of u and du dx's, so I need to get cosine of y in terms of u. Now realize that sine squared of y plus cosine squared of y is equal to 1, and so cosine squared of y is equal to 1 minus the sine squared of y. So cosine of y is equal to plus or minus the square root of 1 minus sine squared of y. Okay? Now, I can't put a plus or minus square root of 1 minus sine squared of y in there in place. So I need to figure out which of these branches is appropriate, and in order to do that, I'm going to think about my unit circle. If I think about the arcsine function, it's defined in 2 quadrants. It's defined in quadrants 1 and 4. And what I know about the cosine in those quadrants is that it is always positive. And that enables me to represent cosine of y as the positive branch of this function. So cosine of y is equal to the positive square root of 1 minus sine of y. And then, since sine of y is equal to u, I can replace the sine of y in this expression with a u. And now I can substitute that back into our original derivative. And I end up with my derivative rule for the arcsine. Okay? Alright, next, let's develop the rule for arctangent. So we'll take the same approach. We'll set y equal to the arctangent of u. And then we will take the tangent of both sides. To get tangent of y equals u. We'll take the derivative with respect to x. So we've got secant squared of y, dy dx, equals du dx. And so dy dx is equal to 1 over the secant squared of x times du dx. And we go back to our Pythagorean identity here. We know that sine squared of x plus cosine squared of x is equal to 1. And from that, we know that tangent squared of x plus 1 is equal to secant squared of x. And so I can replace the secant squared of x here with a 1 plus tangent squared of x. And now, that should be a y. Tangent squared of y. And now we know that tangent of y is equal to u. And so we'll replace that tangent of y with a u. And we get that dy dx is equal to 1 over 1 plus u squared times du dx. And there's where that rule comes from. Alright, that's where we're going to stop the video for here. The next video we'll look at the derivation of the derivative of the arcsecant of u, and then we'll look at a few examples of using these rules. And then we're done with this unit. Alright everybody, hope you enjoyed it, have a great day, and see you next time.